Hello everyone and welcome to the video you've been waiting for. So, the SN6 F-111 3D printed RC plane files are right now public for free. So you can go to the description, you can go to the link, it will bring you to this page right here. You can find the files here, you can download them, and you can print your own F-111 and fly it. And all of this is completely for free. I've decided to put it up just like this. And basically the reason why I decided this is that SN6 works, the design is good enough that you can use it, and I was just gonna keep developing it so this design would never see the light of day again. And I thought it's just like too bad. I wanted to give this design a chance to, be used. And what I ended up deciding is that this is still far away from what the finished product will be, that I can put this up as like the free version of the project, and then once it's fully finished, once the swing wing works, once the retracts are in and stuff like that, that I can then put up as like the full version for, a little bit of money in return, because I did put a lot of time, effort, and also money into this project, and I'd like to, get something back for it. But this version will be the free one. Like, this one is smaller and it doesn't have all the features, but it's still an F-111 and it still has a very good thrust to weight ratio. But you'll notice that this is different. In this video, I said the thrust to weight of this is 1.67, and turns out I was actually wrong. It's 1.17. I don't remember where I got the 1,000 grams of thrust number from, but it's wrong. The actual thrust is closer to 700 grams, so 30% lower than what I thought. It still means that this has a positive thrust to weight ratio because the plane is just 600 grams, but it means that the bigger prototype SN7, which is basically almost done, like if I can, I'll fly it tomorrow, that one will not have a positive thrust to weight anymore. It'll sit at 0.85, which is a bummer because I did buy 2 extra 40 millidFs for it, and now I might have to replace them with 50s or 64s to get a positive thrust to weight again. I'll still fly it as is. Like, 0.85 is still plenty. Like, having a positive thrust to weight wasn't a design goal of this, it was just a nice to have. And I'll advertise it because an F-111 with a 1 point something thrust to weight is absolutely insane. But yeah, it's not as good as I thought it is. It's still pretty good though, so just that major difference is there. And that's also why I'm re-recording this video now. I already had this like done, and then I noticed the error, and it was like a big enough error that I'm gonna have to redo all of this. So yeah. We're gonna go through the description of everything, and like I'll just like basically read this to you, but also give some extra info to it, and then we're gonna take a look at the CAD model, and I'm gonna show off a couple more things. Like, basically this video is just the announcement that it is public now. You can get the files, but I want to add a little bit more stuff in this video, so just let me ramble for a couple minutes. So yeah, in the listing, we just have the 2 videos. This one's public, this one's just the test flight, so if you don't want to watch the rest of the video around it. And then we just have some technical specs right here. How many channels you need, what the wingspan is, what the weight is, what the corrected thrust is, what battery I use, stuff like that, like the flight time. You don't need a gyro, stuff like this. We'll get more into that in the lower section. Important bit is the recommended print settings. And I do actually provide a profile, because I have the main file right here. So this is just the plane file. And then this is a project file that you can open in Prusa Slicer. And this will already, this includes the print and filament profiles for lightweight PLA that I used for this plane. So you just have to put in the stuff for your printer, like just select your printer profile. And then the rest is like already ready to print. Like if you go on the model viewer, yeah, this is just the plane, so you can see how it assembles, how it's supposed to look like. And then this is the project file, and we have all the parts already oriented properly for printing, and we also have them separated into the left ones for lightweight PLA and the ones on the right for regular PLA, because like the you know, the control tabs and the wing plugs and stuff like that, that should be regular PLA because you don't want these breaking. So yeah, it's already separated and everything. So like you can just open this and then one by one print out the parts with the provided profiles. So you don't really have to do much. The only thing you need to provide here is like a profile for your specific printer. So yeah. So, but general guidance is, of course, we're using lightweight PLA, and then I give a range here because it depends on your specific printer, but I print 250 degrees, 45% flow, 4% gyroid infill, and 40 millimeters a second. That's what I do. Put the acceleration just as high as your printer can handle, because faster travel moves means less stringing, because for lightweight PLA, no retractions. You can't retract lightweight PLA. I have a whole video about like printing lightweight PLA where I go into this more, but you can't retract lightweight PLA. It expands, it forms up, and if you suck that back into the nozzle, it's gonna A, burn, and B, cause a clog. Not good. And important thing here is also that the outer walls should be 0.5 millimeters instead of the default 0.4. Essentially, this makes the entire 45% flow thing work, because this is a very low number. Most people play around it like 55 to 65. And there's an ambulance coming close. I'm very sorry about that. Yeah, so this makes the low flow number possible, and this decreases the overall weight while retaining strength, because the first thing they teach you in like, well, I got it taught in university class, but you might get it in regular school depending on where you are. If you have something that's load-bearing, the main stress, like the highest amount of stress, is on the outer skin, because in the middle of the part, like the compressive and tensile strength, they cancel out and you have no stress whatsoever. So the idea here is that, well, the same is true of the plane. So we want the strongest possible outer skin, and we want to save weight on the inside where, the stresses are lower. So I printed 45% flow to make the part very light, but I increase the outer wall thickness to put some more strength into that again, and this results in a part that's overall lighter, but has about the same strength as a regular part that's just printed with higher flow. Because, well, the walls are 20% thicker. And since the walls are the main load-bearing part, it's basically 20% stronger, but doesn't weigh much more, because, like, all the infill stuff is at a much lower flow rate. Yeah, you can also vary the infill line width, and this will not affect weight, because the slicer will actually compensate for this. If you print thicker infill lines, they're gonna be stronger, but you're gonna have less of them. So this, like, again, depends on your liking and your printer. Maybe it's better printing thick lines, then maybe this is better. I do mine at 0.4, but it's an option you have. And yeah, if you're using Prusa Slicer, which, I mean, I do, the file I provide is for Prusa Slicer, you should turn on avoid crossing perimeters, because that makes the printer travel inside the part whenever it can. So like all the stringing that happens while traveling, it's going to end up on the inside of the part where you don't see it, so you don't need to do as much post-processing after the part is done printing. Then, here's all the stuff you need to buy extra to get the thing to work. And quick, rough math, I went through the cost of everything, and including filament cost, but not including the cost of a receiver, this thing costs about 185 euros to build, so it's not cheap, because like you need 2 ESCs, you need 2 EDFs, and I also included the cost for a LiPo battery. So it's about 185, plus another 50 if you also count the receiver, minus 25 if you don't include the battery. So that's about the cost, and like these are the specific parts. So you need 4 carbon rods, 2 of which a 2mm thick, 95mm long for the tailerons, and then 2 3mm thick carbon rods, one with a length of 800mm and the other 480 for the wings. You will see this is different now, because we're now at 3mm, because my SN6 was at 2 and that was not strong enough. The wings kind of got a bit bendy and I was a bit sketched out, so I increased the thickness of the carbon rods. For the servos, literally just get generic, you know, micro servos, like if you search 9-gram servo on AliExpress, the servos I used were MG90S servos. They have metal gear trains, which is complete overkill. You don't need that, and adds unnecessary weight. You could use something like an HXT900, I think, was what I used before. Those are plastic gear trains, and they're lighter. They're actually 9 grams and not like 15 grams like the metal gear train ones. Just that, like generic micro servo stuff. For the EDFs, they're specifically built for the X-Fly Galaxy X4s with 5000 kV. Those are the ones I used. And yeah, like the model is specifically built to take those EDFs. If you want to use other EDFs, you might have to modify the mounting point for them because it's very specifically modeled for that one EDF to go in there. For the ESCs, just get whatever you want in 30 amps or better. I used 20 amp ones on mine, and it did survive the first test flight, but the EDFs pull 20 amps at full power, and I don't like redlining the ESCs because once they get hot, they're not going to be able to handle those 20 amps continuously anymore, and you might have a little in-flight fire, which is not great. So I recommend 30 amps. I actually went with 40 amps for SN7 because like these Fly Color Francie 2, and there's another ambulance, Jesus. Yeah, these Fly Color Francie 2 ESCs that I use, they're available in 20, 30, 40, 50 amps, and like the 40 amp ones were basically the same price as the 30 ones, and I was just like, well, if I end up upsizing the EDFs, they also work for those, so I'm just gonna get the 40 amp ones. But like, for this one, you don't need that. Yeah, so battery 4-cell 1300. That's what I flew with. There is enough space and also enough thrust to carry a bigger battery. So if you go to a 4-cell 2200, that's going to add about 80 grams of weight. So you're going to have a very slightly positive thrust-to-weight ratio still. The plane will probably fly with that. I just haven't tested it, and I can't tell you how it affects like maneuverability and stuff, but it should fly with it. Like, because yeah, you're still gonna have a positive thrust to weight, just like barely though. Yeah, for control linkages, I use 2mm spring steel rods, and you need about 400 millimeters in length for them because the two linkages are like 20 centimeters in length. So just that. And then for the covers, the big cover, so the one back here, I hope you can see my cursor, otherwise this is really annoying. Yeah, but like the aft cover attaches with magnets, so they are 4x8mm round magnets. Just get 4 of them, put them in the holes with like hot glue or whatever, and then you have a magnetic cover. And then the front cover is attached by, yeah, with like steel wire that I bend in place. It's not a great mechanism, but it's what I had, and I haven't found a better way to do it yet, so it's still in the release version. But yeah, you just have a set of holes. You put 2 like steel wire or like any kind of metal wire you can easily bend by hand through that, and it holds the cover on. It's not great. If you fly with the 1300, that's also where the battery is, so it makes it a bit annoying. If you fly with a heavier battery, that's going to be further back, and you can probably access it through the cover B. But yeah, it's not a great mechanism. I just haven't found a better way to do any of it. So yeah, it's unoptimal, but it works. And then here we have a bunch of notes. So first off, just because of how the F-111 is built, the pitch axis is very sensitive, but the roll axis is not. So the ailerons are massive, so that's why the pitch axis is very sensitive, but they are also very close to the plane's roll axis, and that's why they are not effective in roll. They are massive, but they're very close to the roll axis, so you're gonna need a lot more roll throw than pitch throw to get the same kind of responsibility for control. So keep that in mind when you set up like your expos and stuff. Already touched on this, you can probably fly with up to like a 4-cell 2200. It has enough thrust, it has enough space to carry it. It's just I haven't done that, so I can guarantee you it works. It's just like it should work, I just can't guarantee it. CG marks I found at the bottom of the wing parts. This is one of the new things because I didn't know what the CG would be before, but right here you can see this bar, and CG should be like where this bar is. The other guidance is just as long as it's in front of these two wing plugs, you're fine. Because like this is where I had the CG for my test flight, and with the engine off, it was gliding pretty much perfectly. So yeah, just the CG was like this is fine. You should probably not put it behind that because, like, do it at your own risk. This is where I recommend it. But yeah, this is one of the changes to the model. We're gonna take a look at the CAD model in a bit to show all the differences. But yeah, it has a CG guide, so that's probably useful. Yeah, it goes very fast at full throttle. The plane isn't that big, and it has a positive thrust to weight. So once you throw it, you basically have to turn immediately, or it's gonna fly out of visual range. It's just keep in mind, it's not easy to fly. Yeah, so you need a print bed, like roughly end of 3 size. It fits on a 220 by 220 just fine. It probably fits on a Prusa. I'm not entirely sure if the Prusa printers have like the Z height needed for that, because the center wing parts might be close to the 250, and I think Prusas only go like 220 high, so I'm not too sure about that. If you have like a Bambu A1 Mini, it probably won't fit. You might have to cut some parts in half for it to fit, because like I don't have a printer that size. Like the smallest printer I have is about that size, and it fits on that one. So yeah, if you have something like this or bigger, you're fine. Everything can be printed without supports. I designed for that. I don't like supports, so I designed every part to be printable without supports. You don't have to enable it for any of the parts. They all go without supports, so yeah, just fine. You don't need it. And yeah, I already alluded to this a bit. You should have experience with EDF jets before you fly this one. It's very fast. It's kind of small. It doesn't have a very responsive roll axis, and it's an F-111. There's not a lot of lift. There's pretty high wing load. Stalls in this might not be very easy to recover from. So you should have flown at least one other EDF at some point before you fly this, is my recommendation, because it's not an easy plane to fly. Yeah, it's 3D printed, it's really easy to fix when you crash it as long as the electronics survive. But like, if you don't have EDF experience and you fly this, you're probably gonna crash it. That's just, yeah. This is not a beginner plane. Like, it is not a beginner plane. You should fly something else. You should fly an EDF with much lower wing load and much more lift before you fly this, because yeah, probably like if you stall this at a low altitude, it's probably over. You're probably not recovering. And yeah, the last note is that I miscalculated the thrust to weight before, because I say it in this video that's 1.67. It's not. It's closer to 1.17. So yeah, just said that. And then the last thing is the license. So this is licensed under attribution non-commercial, no derivatives, so you sadly can't remix this, at least officially. The reason why I did this is because, well, I will be developing this into a more advanced paid model at some point, so that's why I don't want, you know, that. Yeah, it's like, it's mainly about that this is supposed to be the free version, and then if you want the advanced features, you should go to the paid version, which will be out later. That's basically why this doesn't allow remixes, at least as per the license. If you want to do small things, like we already said, if you want to use a different EDF and you modify the mount for that, and you want to publish that as a remix, I don't have a problem with that. I'm not gonna tell you to take it down. I don't know what Printables is going to say about that, but I won't tell you to take it down. Or if you want to, like, do other things, like, I don't know, add more detail to the model, or like change the wing shape to something else, or like experiment something. It's perfectly fine to do that. Just like, don't use this as a means to like get the paid model for free by like adding in exactly what the paid model has in extra features and then put that online. That's not what I want to happen. I don't think that's going to happen because this model is quite a way off from that, and it's like the amount of effort you would put into adding all those additional features, you could just design your own plane and then not have any licensing issues. So I don't think this really is a problem, but that's why I chose the no derivatives license, which sadly makes remixes like officially not a thing. But like, as long as you do them in good faith, I don't have a problem with that. I just don't know what Printables will do if you do that. So, yeah. And then with that, I guess it's time to look at the CAD model, which is right here. So, this is the version that's up on Printables right now, and it has changed in a few ways. So first off, all the writing that I put on with a stencil is now actually part of the model. So the way how this is done is there's a very, very tiny indent. It's like 0.1 millimeters. So this is not gonna affect aerodynamics, but it's gonna make the printer printed in a way that it's just visible enough that you can then color it in with something. So yeah, it doesn't need a stencil anymore. I also added, my logo to it because it is my design. And I'm putting it up for free, so I at least want the advertisement or something like that. But yeah, so added a bit more detail. Again, also like the CG marks are also added in this way. I added multiple versions of the control tab, so the one at the top is for 2mm rods, the one at the bottom is for 1mm rods, depending on what you want to use. And then there's also some smaller fixes, like there were some errors in the model. I reworked the wing box area a bit more because there was more empty space here for my SN6 that I built, and I was a bit sketched out because the roof here gets very thin, and it didn't break, but like I don't want to tempt fate too much, so I reinforced this area a bit, filled in as much as possible, so this is more rigid. And I also removed some internal structures right here. Like this is now completely free, which is going to improve airflow a little bit, and you should maybe get a little bit more performance out of that. So that's going to help a tiny bit. So smaller reworks and stuff like that. Yeah, so that's the model. It's still pretty much SN6 as it flew. So yeah. And with that, I guess that's everything I wanted to say. So thank you for watching. Have good fun with your F-111. Download it, print it, fly it. I would appreciate if you like add a make or something, so like I can see actually people like flying this, because it would be really cool to see people like use my designs. And with that, I hope this is the best outcome for everyone, that these plans get to be public and that I still get to get a little bit of return on the finished model. So yeah, I hope this is like the fairest way to do it. And until next time, goodbye.